Hi guys, in this video we're going to have a look at trigonometric graphs. So the three that you need to be aware of are the sine, cos and tan graphs, which I have here. So I'm going to have a very quick chat about what you need to know or be aware of, because you might be asked to sketch these in the exam. So let's start off with the sine. First of all, it's a wave. It will carry on going forever and ever, and it will also can go into the negatives, which we'll have a look at later on. The sine graph always starts at 0, and then we go up 90, 180, 270, 360 for our key points. So the first one to note is it goes from 0 and it goes up to 1. So at 90 degrees we have 1, 180 degrees back to 0, 270 to -1, and then 360. And this just continues on forever and ever and ever. So key things, starts at 0 and it goes between 1 and -1, and it never goes past 1 and never goes below -1. The cos graph here, exactly the same curve, however it starts at 1. So the sine starts at 0, cos starts at 1, and again we've got our key bits here, 90, 180, 270, 360, and so we go to 0, to -1, to 0, and then back up to 1 again. Okay, so these are exactly the same curves, it's just the starting point here is different. Tan is the one to be careful of. Tan, we start at 0 here, and we start off really low, and as we reach 90, we go zooming up here. Now we never actually reach 90, as we get closer and closer, it's like 89.9999999 degrees or whatever. We get ever so close to 90, we keep going up, closer to 90, but we never actually touch 90. As soon as we go over 90, we start at the bottom here, again, not actually on 90, but close to it, and we come back round, down like here, and we cross at 180, that's fine. And then we go back again, and when we hit 270, we go really close to it again, but never actually touching to it. Notice here the scale is 10 upwards. This carries on going forever and ever and ever, but again, never actually touches 90. And if you try on the calculator, so if I put tan 90 in like that, you'll see it comes up with a math error because it just doesn't exist. We never actually touch 90 degrees here. Same with the 270. If I was to put in tan 270, again it would just error like that. Okay, so again it gets very close to it, never actually touches it. As soon as you go over 270 again, we start that process again. So that is the tan graph, and we have the sine, cos and tan. Now, you could be asked to sketch any of those, but the ones I tend to ask questions about are the sine and the cos, which is what we're now going to have a look at, some of the most common questions that you could get asked to do with regards to trigonometric graphs. First one here is which values cannot be the sine of an angle. So if we have a look at our values here, we've got 0, 1, a third, or 0.3 recurring, minus 0.5 and 1.8. And if you remember, on our graph, our values are always going between 1 and -1. So which one can it not be? It has to be this 1.8, because 1.8 is somewhere up here, and therefore it's off the scale. It definitely won't be the point that we can get from an angle. Okay, so that's the first one there. Always between 1 and -1, so 1.8 is out. What are the coordinates for the highest and lowest points of a sine graph? So here I'm looking at the sine graph. So the highest point, and notice it's between 0 and 360 degrees. So the highest point is easy. It's going to be this point here. So the coordinates of that, remember, x is on the corridor and then obviously y up the stairs. So the coordinates there for the highest, I'll just put h for highest, is 90 degrees. And then obviously we'll have 1. Remember, the maximum point is 1. Lowest point would be here. So I'll just put L for lowest point. So again, the 270 is my x value, and the lowest point is -1, never goes past -1. So there we go for the coordinates there. Notice here I have a slightly different range. As I said before, this graph continues going on forever and ever and ever. So if you were to, you could sketch that, that's not a problem, you can absolutely sketch that. But to save having to do that, it just repeats itself. Every time, it just repeats itself. So what you could do is you could label it like so. We say 0, 90, 180, 270, 360, and then underneath that, we could just repeat ourselves. So for example, the 360 point here is the same point here, then if I add 90, I would have 450 degrees. Sorry, I should put my degrees in there. If I add 90 again, I'll have 540 degrees. And then add 90 again, it'll be 630 degrees. And then finally add 90 again, I would have 720 degrees, like so. Which is just basically, I've looped once and I've looped it again, I just carry on going. So to save drawing it, you could just write it again. And again, if you need it between 720 and whatever, you could just come back again, do 720 and keep adding 90 to save you having to draw it. Now, if you prefer to draw it, go for it, it's not a problem. This just saves you a bit of time. So again, if I wanted the coordinates here of the highest point between 360 and 720, well, 360 starts from here and it goes all the way to 720. So the highest point would be 450 is my x coordinate, and the y coordinate would still be 1 because obviously 1 would still be the highest, and the lowest would be 630. And again, lowest there would be -1. So you could do it that way to save having to draw it and find out exactly where it would be. You could do it that way. Just write the scale out, repeating it. Okay, so there's some of the common ones that you could have. Values that aren't relevant. And then the highest and lowest coordinates. Again, just doing what I did. Could I be asked for a cosine? The cos graph here. So again, that would be like the highest point would be 0 and 1. The lowest point would be 180 and -1. Okay, so let's have a look at some more questions. Here we go. So, again, just the same graphs. This one is very, very common, this sort of type of question. So one solution of cos x is 0.5 is x equals 60, so 60 degrees. I put the 60 degrees there, although x would technically just be 60. What that means is that on my cos graph, if I put x is 60 or 60 degrees, so this has been deliberately split up, so 30, 60, 90, all that means is if I go up to from 60 across here, so go up to here, have I got a ruler? Yes, I have. And then go across, that means I have my 0.5. This is all just not to scale, but you get the idea. 60 degrees going up and across to 0.5. So it says, find another solution for cos of x equals 0.5 for in the range between 0 and 360. So again, the 0 and the 360 here. So where else do we have this here? If I go across here, all the way across, all the way across here, where do I reach that point again on the thing? Well, it's going to be here. And then I can just come down and I can figure out what the solution is. So obviously this is quite a nice one. We can see that we've got 270 here. Next bit there, that would be 300. But let's just say that wasn't quite as nice. What you can do is go, okay, well that point there, I've gone from this point where it's at 0, so the same point would be there, I've gone 30. So what you could also do is go 30 that way, so 270 plus 30 gets you the 300. So the solution for here would be x equals 300. Okay? Again, just like we did in the first bit, it could ask you for the the range between 360 and 720. So again, what you could do, you could draw it if you wished, or you could just repeat it. So you've got 0, 360, here would be 450. Again, these are degrees, sorry. And then 540 degrees. And that one there would be 630 degrees. And then obviously we have 720 degrees. Okay, so again, what would it be? Well, it's going to be the same points here. So this bit here, if that was 450, I go back 30. So that would give me 420. Or this one here, I would have 630, add 30, so x could also be 660. So there's my two solutions for the range of 360 and 720. Okay, we could have something like this. Use the graph to estimate a solution to sine x equals 0.8. This can be an estimate because there's no actual true way of doing it, just need to get a rough idea. So all I do is on my sine graph, I have a look roughly where 0.8 is, which is about there. you get a nice horizontal line going across there, and then we can come down here. Now, again, this is split up, so that's going to be 30 and that's going to be 60. So, what would that be? Again, it's only an estimate, so it doesn't have to be anything too posh. But I don't know, about what, 55? If we go in between there, it's about 45, so about, I don't know, about 50, something like that, 50, 55. So if we have a look at our calculator, if I was to do the inverse sine 0.8, well yeah, look, 53.1, so yeah, 50 or 55, something like that, from your line here. Let's go with 55, would be absolutely fine. Same way, doing it with this one here. This time I have cos 50. So all I do is on my cos graph, from 50, well if there's 60, obviously 50 would be somewhere about here. Go across, and if that's 0.5, we're probably looking about 0.7. I'm going to go with 0.7 as my estimate. So if I put that in, cos 50, 0.64, so yeah, we're not far off. It's only an estimate. As long as you can prove what you're doing by drawing your lines, your estimates will be absolutely fine. So that's another type of question that you could have. Right, last one. Here we go. So one solution of sine x equals minus 0.5 this time is x is 210. Find two more solutions in the range between minus 360 and 0. So this is where the negative comes in. So if you're given a graph and you have to draw it, again, just draw yourself a quick sketch. So this is the sine graph. So with sine, remember we start off with 0, and then we go up 90 to 1. Then back down to 180 to 0, then down to minus 1. Notice I've got my 90, 180, 270 and 360 here. So again, I'm going to try and draw this nice as best I can. And it does help to twist the paper around so you naturally go with the curve of your hand when drawing these. Again, this is just a quick sketch. As long as you've got your key points, that's absolutely fine. So there's what we know. And like I said, it just continues. So the next point here, if we're going to go into negatives, would be there, then to 0, then to 1, and then back down to 0 again. So again, we can then just draw those as best you can. Like so. Not too bad, not too bad. Okay, so let's tackle this question. So one solution of sine x equals minus 0.5 is x is 210. So 210, if we do the same thing, breaking this up, just go up in 30, so 210 would be there, because 240 would be there, and then we've got 270. So 210 is here, so it's going to be this point here. So at 210, we have minus 0.5. If I was to come across here, this would be the minus 0.5 bit on our y-axis. We need to find two more solutions between this range here. So all I'm going to do is I'm going to get my ruler like so, line them up as best we can, and I'm going to have this bit here and this bit here. Now, to be more accurate, they'll probably give you this graph, but I just wanted to show you about the sketching bit as well. So, to go from the 0 point here, which is also here and is also here, we go from 180 to 210, so the gap between these two bits here is 30, which means the gap here between our 0 point and where we want will also be 30, and the gap here between our 0 point will also be 30. So my two solutions will be 0 going down 30, so I'll have one solution which will be x equals minus 30. Remember, we're going into negatives. And this one here, well, it's going at this bit here at 0 is minus 180. I'm going back up 30, so then that would be minus 150. Okay, and you can do a little check if you wish. So if I was to do sine 210, we have the minus a half, which is what we said. So we can also check it. This is assuming you have a calculator in this particular bit. So sine minus 30 minus a half, so it's the same. Brilliant. And again, sine minus 150 minus a half, so they're all the same. So you could double check it if you had a calculator as well. So they're the most common types of questions that you could have. Should be able to, or might be asked to sketch the graph. Just remember, sine starts at 0 and then goes from 1 and keeps going. Cos graph, exactly the same as the sine graph, but starts at 1 and does the same thing. And then finally the tan, I'll just go back to the tan one just as a reminder. Start at 0 and goes up as close to 90, but never actually touches 90. As soon as you go past 90, we come back down again and we go like that. Okay, so you could be asked to sketch them. You could be asked about the points. Remember, between 1 and minus 1 for the sine and cos. Tan can go up forever and down forever. And then the solutions, just remember your angles, going across and find the same point on the curve. If you remember those things, guys, you shouldn't have any issues with trigonometric graphs. So hopefully that helps. Thanks for watching. Cheers.